Hello and welcome to Mr. Connolly's Math. Today we're going to be talking about slope-intercept form and its applications. The first thing we're going to do is in example 1, we're going to find the slope and y-intercept. Now if we know that the slope is m and the y-intercept is b, then if we look over in this problem, it's pretty easy. The slope is going to be this number next to the x, so the slope is going to be -6. And over here, the y-intercept, you see this is an 8, but actually think of this as a -8 because that's the same as plus -8. So for that reason, since y-intercept is expected to be adding the y, then that means that this number is actually -8. So we say that the y-intercept is -8. Okay, let's look at example 2. Now in this equation, we've got y equals something x plus something. We want to actually write the equation, and this time we're given the slope. The slope in this case is 7. And the y-intercept is 4. So if you think of it like substitution, if the slope is 7 and the y-intercept is 4, all I need to do is substitute them back in. So the 7 will go here, say 7x, and the y-intercept will go towards the end. It's a positive 4, so we're going to say plus 4. So the final answer is y equals 7x plus 4. And that's how you write it in slope-intercept form because the slope is next to the intercept. Let's try example 3. In this example, I'm given a line and I need to find the slope and the y-intercept by looking at the graph. So on this type of problem, I want to find the parts of the line where it touches an easy point. So right here I see this is the intersection of some of the grid lines. So right here would be the first spot. You would see it be what, 0, 1, 2, 3, 4 up. So this is 0 and up 4. And then I go along the line, I try and find where there's an easy intersection. Up right here is an easy intersection, and that's an easy point to name. That'll be 1, 2 over, and 1 up. Okay, so now I've identified 2 points on this line. So to find the slope, I need to count the distance between the rise and the run of these 2 points. So I'm going to start at this point, and I'm going to go 1, 2, 3, and since I went in the down direction, that means it's -3. And now I'm going to go to the right, 1, 2, and since I went to the right 2, that's considered a +2. So we know that slope is the rise over the run. Sometimes rise can mean we go down. In this case it does. So since this went down, the rise is -3, and the run is going to be 2. So I just take this information and I substitute it right in front here, and I say -3 over 2x. And now I need to find the y-intercept. The y-intercept is where x equals 0. And lo and behold, I have one right here. This point that I already named, 0, 4. That's going to be x equals 0 and the y equals 4 in this case, so we say the y-intercept is 4. So I'm going to take this 4 and I'm going to put up here, since it's +4, I'm going to put +4. Ah, that's better. Okay, next we're going to do example 4. Example 4 asks, determine if the point 1, 6 is on the line y equals 4x minus 2. To do this problem, we're going to substitute 1 and 6 for x and y, and if we get a true equation, then that means that it is a solution to the equation, and therefore it is a point on the line. So first what we're going to do is evaluate. So in evaluating, our first step, remember, is to substitute. I'm going to substitute x is 1 and y is 6. So I'll say x for 1 and y for 6. So I rewrite the equation. Substituting, instead of y, I'm going to put 6, and then 4 times 1 minus 2. Now we simplify. That's step 2, using the order of operations. So first we look for parentheses. There's parentheses, but there's nothing to simplify. Then we go to exponents. No exponents. Then we go to multiplication division. Okay, there's some multiplication, so we'll do 4 times 1, which is 4. we've got minus 2, that's the addition subtraction step. And 4 minus 2 is 2. So I have 6 equals 2. Now this is definitely not true. So what we need to do then to determine our answer is, we've already determined it. If 1x is on 1 comma 6 is on the line y equals 4x minus 2, then these two sides would be equal. But since they are not, it's false, then therefore this is not a point on the line. So 1, 6 is not a solution. So the answer is no. It is not a point on the line. Now let's try example 5. Now for the last example. Graph y equals 3x plus 1 using the slope and y-intercept. So this is kind of a shortcut way of graphing a line. So we're going to use the graph map. We're using M and B, which means slope and y-intercept. So the first thing we want to do is identify the slope and the y-intercept. We know the slope is going to be the number next to x, so that's 3. And since we want to write this as a fraction, it would be 3 over 1. The rise of 3, a run of 1. And then this last number, the positive version of it, is 1. So that means the y-intercept is 1. Okay, so first we start at the y-intercept, which is going to be 1. So y equals 1, that's where x equals 0. So that means we start at the y-intercept, which is at 0, 1. So I go from 0 up to 1. And there's my first point of the line. Now I follow the rise. We know the rise is going to be plus 3, so that means I go up 3. So now I count up 1, 2, 1, 2, 3. Okay, and now I use the run, which we know is going to be 1. It's positive 1, so it goes to the right. 1. And that is now my second point. So 0, 1, and this point, which is 1, 1, 2, 3, 4, are points on the line. Since I have 2 points, I can draw a straight line. So I just draw a line through those 2 points. And now I have my line. Nice, quick, easy way to graph a linear equation using the slope and y-intercept. That concludes the tutorial. Make sure you fill out all of the information that you see on here. If you have any questions, let me know tomorrow. Good night.